Hey, what's up, everybody? Welcome to the Thursday live stream. I don't know why. Hold on. I don't want to show this yet. We'll get to that. All right. Why? I can't. There we go. All right, everybody. It's going to be a great show. Welcome. What is up? What's up, Theorem Geek? How's it going? Yoshi Kuniful? Hello. How are you? Harry. What is up, Harry? What's up, Christopher? Thanks for being here, y'all. It's Thursday, and it's almost the holidays. And I don't know about y'all, but I'm just trying to get through to some vacation. We're just powering through the home stretch. What's up, Ashish? How's it going? Android Terminal. Hey, good to see you. What's up, Nicholas from Argentina? What's up, Argentina? So Tito, Mage, good to see everybody. We got a great stream today. This is going to be quite interesting because we're actually going to do some LeetCode. We're gonna solve some LeetCode with VS Code and show y'all how to visualize some of that stuff that's kind of complex. But before we do that, I wanted to show y'all something. If you're not already subscribed on YouTube, first of all, how dare you? And then second of all, we posted over on if you are on YouTube, if you go to the community tab, I've posted this form here where we're asking people to upload pictures of their dev setup with VS Code running in the background. And then 2 weeks from today, we're going to rate those on a stream. We're going to do a whole stream because we got a ton of them. I'll give you a quick peek here. These are some of the 50 odd setups that have come in so far. So if you want to be part of that, make sure you put that here. It does require a Google address, but if you're on YouTube, you've got one of those, right? You've got a Google address. What's up, Ben? Pascal, how's it going? What's up, Lennon? How are you? Hello from the Dominican Republic. What's up, Dominican Republic? What's up from India? Sweet. It's so great to see all y'all here. All right, let me stop sharing. Was I going to show you something else? No, I don't think so. All right, so y'all, today is Thursday, and that means it's Thursday TikTok Throwback. Did I do that right? Is that the right? Producer, roll the segment. It'll tell us. Throwback.
Faces you make when you don't know the answer.
All right, grab a seat. Great job answering those algorithm questions. Seems like people like you. Okay, just a couple of easy questions and we can wrap this interview up. If you can't Google but wanted to learn how best to describe Azure Cloud Concepts, where can you look online? I can't Google it? No. Let's try another one. You want to learn about DevOps. You can't Google. Where can you look?
Can I Yahoo it?
No. All right. You want education topics on Microsoft products. You can't Google or Yahoo it. And you can't Bing it either.
Throwback TikTok there, so I'll get it right at some point. With that, yeah. I've been there. Describe inverted binary tree Burke. Like right now, without Googling it? I don't know, but we're actually going to do that on the stream today. So, folks, exciting because we have with us today a gentleman who's done a lot of work in this area and in visual. Nobody told me about that. Producers, look at this. My gosh, I'll just put it down. Yes, his name is Henning, and yeah, we put together a little intro. So listen, go ahead and check that out. The computer stores everything in its memory as a sequence of zeros and ones. But for us humans, it's hard to make sense of this data, especially when we're implementing or debugging complex algorithms. While modern code editors and debuggers, such as VS Code, already help make sense of runtime values, we can go one step further. What if we could use advanced visualizations and draw, say, a linked list or other values as they change in our code? Watch this live stream with extension author and VS Code engineer Henning Dieterichs as he demonstrates how his VS Code extensions can be used to make sense of complicated data structures. All right, so please welcome Henning Dieterichs to the live stream. What's up, Henning?
Hi, Burke. How are you?
Good. You didn't tell me about my coffee stain prior to the, I'll show it over here, prior to the stream. Did you see it? You can be honest with me. Okay. Well, hey, welcome. Listen, quick question for you. You work on the VS Code team, yes?
Yes.
You're an engineer.
Yeah, and mostly I work on the core editor and worked on features like bracket pair codification or inline completions.
And how does one go about getting a job as an engineer on the VS Code team?
So I think for me, it was the extensions that I made before I applied. And then I think that was like a bonus when I applied. So I think they already knew my name.
Did they ask you to invert a binary tree? Did you have to invert any binary trees on any whiteboards?
No, they asked me some other algorithmic question.
Were there any that you just didn't know, where you were like, I have no idea how to solve this?
So in this interview, I had an idea how to solve it, but in my preparation, I had some problems where I had no clue whatsoever.
So you actually prepared for the technical interview with the VS Code team?
Yes.
Did you use LeetCode when you did that?
Yes. Yeah. I used various websites, I think, but some of them were really complicated, and
yeah,
I struggled.
Some of the questions are super hard. Chat, do y'all practice LeetCode? Just wondering if other people do this. I see this a lot. I do it myself sometimes, and sometimes it makes me feel good about myself, and sometimes it makes me feel really bad about myself, especially if the question's marked easy, and I'm thinking, I have no idea how to implement this. Not the first clue. Chat, do you do LeetCode? Do you LeetCode in your free time? This will be interesting. Sometimes, yeah. I'm just curious as to how many people actually LeetCode all the way. Yeah, how many people actually do it? Anybody done all the questions on LeetCode? Is that even possible? I don't know. It'd be like an achievement for that. I've solved every LeetCode question. I do LeetCode for prepping for interviews. Yeah. There's another website I found called NeetCode. It's neetcode.io. And it's a gentleman who is an engineer, I think at Google. And he basically takes like something called the blind 75, I think, where it's like the top 75 questions that you get asked at like Facebook or Meta or Microsoft or Netflix. And he solves all of those in Python and shows you how to do it. Super helpful. All right. LeetCode? HackerRank, yeah, that's a good one too. All right, Henning. So what are we doing? I'm setting all this up because we're talking about all this today, right? We're gonna show how to use VS Code to make solving these problems easier.
Yes.
All right.
So I brought two extensions with me. One extension is Draw.io, and actually, let's start with that one.
Okay.
So it's super easy to install. You just type Draw.io in the search with the extension violet, and then you install it. So Draw.io itself is a standalone application that I didn't do. Some other great engineers did that, and I think it's pretty old. I think 10 or 20 years. So it's also a very stable product. But the extension I made here integrates Draw.io in VS Code, so you can directly create diagrams from within VS Code. Let me show you how to do that. So I prepared a folder here, and I can just create a new file. For example, binary tree inversion.dio. That's the extension for Draw.io files, and then Draw.io loads.
So what exactly is a binary tree, Henning?
So a binary tree is basically a tree that is binary. So each node has two children. Let me start with one. So
in a binary tree, is the left node always less than the right?
That depends on what problem you want to solve. So depending on the order, it doesn't matter. So, but the binary tree should be ordered if you want to insert things quickly.
So it's either the left node is always lower or the right node is always lower, but you wouldn't have a combination of left and right nodes being greater than or less than.
Yes.
Okay. For the balance tree, Theorem Geek says for a balance tree.
Yeah,
all right,
so
cool.
You can use binary trees for many applications, also for balanced trees. For bracket pair colorization, for example, I used a balanced AB tree. Okay, it was not technically a binary tree, but sometimes nodes had 2 or 3 children. And the fact that the tree was balanced made it really nice to quickly find nodes in there.
Gotcha. Okay. So that and bracket pair colorization is built into VS Code, and you used a tree for that.
Yes. So that's really fast.
You do actually use these things in real life, folks.
Yes.
not just on
life.
Yeah.
Yeah. So let me start with creating an exemplary binary tree. So we have the 4 nodes 1, 2, 3, 4. Let me create more space here. And then you have, so this is basically a list, and for a binary tree, you have these parent nodes.
And are you just copy pasting? Is that what you're doing there?
Yes, exactly. So you can click on a node and press Ctrl+C, Ctrl+V, and then you have it. That makes it really convenient, straightforward to work with these edges.
And you're just dragging from those handles to get the pointers.
Exactly. Yeah. So you can also use these shapes here, and here you have various kinds of nodes. Also, if you have a node, you can change the format. So, for example, if you don't like this straight line but want to have this this other one, you can easily do that. You can also select multiple edges and then change them all at once. So it's super handy to create all kinds of things. So now I have this binary tree here.
So what would the values be for the parent nodes?
If you want to quickly test if something is contained in this binary tree, then you can, for example, do the higher value. So here you could store 2, here you could store 4, and here you could store 4. Sorry. So there are many options, and it depends on the problem that you want to solve and how you want to query this tree. But here, for example, if you want to find the node 2, you have, so this one stores the highest node. Now I have to concentrate. The highest node in the subtree, the highest node in the entire subtree. And then you can look at the children. So you know the highest node in this subtree is 2. So you don't even have to look into that. And then this is what, so you only have to make this decision in which subtree you want to descend to once, and then you have the runtime of your search then only depends on the height of the tree.
Yeah, so it's kind of, and that's why they call it binary search, right? Because you're cutting off essentially half right there of things you have to search.
Though so the classical binary search implementation just works in an array that is sorted, and then you don't have to build up these intermediate nodes because you have them implicit by your start and end boundary that then halves every time you iterate.
You know, the best implementation or like the clearest of a binary search that I've ever seen is the bisect for VS Code, the extension bisect. I don't know if y'all have ever used extension bisect, but if you get into an instance where your VS Code is borked or burked, where it just doesn't work, and you're not sure why something really weird is happening, it's likely an extension. And you can run this thing called extension bisect, and it does exactly this. It literally disables half the extensions and says, does the problem still exist? And if you say yes, then it knows that the half that it disabled is not the problem, and it just doesn't look at those anymore. And it does that again. It disables half of the half, And that's the binary search implementation, a very, very practical and simple implementation of binary search. Anyway, sorry, Henning.
Yeah, and for the task that you wanted to do is to invert this tree so that we then have a binary tree that represents the reversed order. Though if we revert it, then obviously we also have to adjust the logic that finds nodes in it, because it's a key assumption that if you want to find something in a binary tree, it has to be ordered, and if you revert it, then it's ordered in the other way. And yeah, we can, here in this in Draw.io, we can just play around with these nodes and see what happens. So one spontaneous idea would be just to order the nodes, to inverse the nodes at the very bottom, like this. Oops. So now we have, we are not there yet, because now the tree says 2, 1, 4, 3. But if we also basically reverse the parents like this, and then we move that all over here, then we have 4, 3, 2, 1, and our reversal is complete.
All right, so now the greater numbers on the left and the smaller numbers on the right, and that's the inversion.
Yes. So and then the idea would be to just flip every children list of every node, and then if you do that at the end, you end up with an inversed tree.
Very nice. So a couple questions here from chat. What is this extension? Sorry, came in late. All right, Tiger, this is the last time we repeat. Otherwise, you got to show up right at 8 o'clock, 10 o'clock sharp. What is this extension, Henning?
Sorry?
This extension that you're using, what is it?
So this is the Draw.io extension.
Draw.io.
You can find it by just typing Draw.io in the search window, and then it's the first one.
Look for Henning's name. There you go. Let's see here. Here's one that's going to be a great segue. Let's see here. 1 second here. So log-in complexity, log-in time complexity on a binary tree, that would be correct. Yes?
Yes. So, yeah, because the height of the balanced binary tree is the logarithmic number of the nodes at the very bottom, or of the nodes in total even. And if you only need to navigate from the very top to the bottom, then that's the logarithmic amount of numbers of nodes that you have at the bottom.
And let's see, I think this is Pavel, if I'm pronouncing that correctly. Good question. And also great segue. Henning, can we generate diagrams from code?
Not yet.
But you can go the other way, can you not?
You can't generate code from the diagrams, but you can link to code from diagrams. So for example, even in this example, maybe it doesn't make so much sense, but let's say I open a file. So this is something that we are going to look at later, linked list, which is the other typical interview question. But now you can select a node here. They can select some code here, and then I can say link node. And now if I double click that node, I jump to the code that I linked the node with. So you can use these diagrams to document your architecture or software design, for example. If these are classes, and it's super easy to jump to the code that you want to document with this.
So what else can we do with Draw.io, Henning?
Many, many things. So I have some demos for use cases here. So what I mentioned just now is one super use case are class diagrams. So if you have some complex structure where you quickly want to describe how classes work with each other, then the class diagram makes a lot of sense. And there is one feature here. You can convert a Draw.io diagram to a SVG file, and then it stays an SVG file. So if you now edit this, like if I add a node, hello world, and save this, then it's still an SVG file. And then if I have an SVG file, I can put it on GitHub or even link it from Markdown files. So for example, if I have a README Markdown file here, I can link to this class diagram. And let's say documentation is the title of this Markdown thing. And then, because it's a, I have to change the theme to theme 9 plus. And
no, right? Chat's gonna lose their mind.
So the issue is that most of the time GitHub. So I think by now GitHub also has a dark theme, but if you embed draw.io diagrams into dark theme Markdown documents, that's a bit of the issue. So for that, you best use the light theme. But here you can see now I embedded the draw.io diagram into a Markdown document, and if you push this to GitHub, then you can also see the draw.io diagram like this on GitHub without needing to install any extension.
Very nice. So you can convert it to a format that you can show outside of Draw.io.
Yes, and I only need to do this once, and then if I do some change like this, save it, then you see the...
it automatically updates. Man, that's really nice.
So the SVG file here is really the ground truth that stores the document. There is no export that I have to do every time I change something. It happens automatically.
That's wonderful. Yes, Skating Yellow Fever. Yes, YouTube, please. Yes, it will be on YouTube. It will be recorded. You may come back and watch at your leisure. All right. All right. What else can we do?
Other use cases, for example, even though there might be better tools for that, but you can use it to design wireframes. So here I once sketched a mock-up of a GUI to just brainstorm how a UI could look like to rearrange PDF pages. And it's just super easy to have these buttons and to brainstorm layouts, put some text anywhere. And it's it's
that's really nice. I didn't realize you could do that.
In fact, there's an entire library of these. So there are these shapes, and so this is all built into Draw.io. The standalone Draw.io application has all the same features. But here there is somewhere the option for, I think, mockups. They have some buttons of iOS if you want to design iOS apps.
Wow.
These are just icons. But so yeah, here under it, UI elements, there's a bunch of stuff that you can use from here.
And this is free? There's no...
This is free, and even better, it's open source.
Oh, wow.
And the Draw.io extension bundles an offline thing of Draw.io. So Draw.io is this website. They are actually called diagrams.net. Draw.io was the name before they changed. But it's all offline. So if I don't think it will happen, but if Draw.io ever disappears, this extension still works, and all your diagrams will be editable forever. And Draw.io, I think, is around for maybe 10 to 20 years. So if you ever make your diagrams in Draw.io, you can be sure that they won't go away anytime soon.
Very nice. I was using, I think, Balsamic for a long time to do this kind of thing. I had no idea that I could do it right inside of VS Code. Not saying you shouldn't use Balsamic. It's a great product, but this is, I don't know. I didn't know you could do this. Very cool.
You can also paste screenshots in Draw.io. So you just make a screenshot and you paste it, and then you have it. So you can easily describe workflows of how you get from this screen to this other screen. And then you can link these screens with code. So if you have a particular React component, for example, that renders this particular page, or if you have a separate HTML page for that, you can associate this file with this node, and when you double click, you will jump to that file.
Wow, that's crazy. So you could annotate basically your whole application in here, so that people jumping in could be like, where's the code for this screen? I just double click and go straight to that code.
For example, I just select this node here, and then I select the README file here and say Draw.io link file with selected node and active diagram. Now it lit up. Now if I double click it, I will jump to the README file here.
Wow. Wow, this is crazy. I had no idea any of this existed in this extension. Somebody had a great question that I had the same question. They were like, can we Does the relative pathing work on GitHub READMEs for?
Yes, it works.
Okay, is
So
that new? Is that
No,
new, or has it always been that way?
it always worked. So if I
Okay.
would push this to GitHub now, so I do it for all my personal projects. If I push this to GitHub now, it will render this diagram in the preview. It will just work out of the box.
And can we export the diagrams to other formats besides SVG?
So there's one other format, and it also supports this embedding. So that's the PNG thing. And now this basically is a PNG file that contains the diagram. So it's also not an X. So you can also export it, but this way, the PNG file is the diagram. So if I open the PNG file here, it's the diagram and the PNG, the image at the same time. And now this image, you can also use it instead of SVG, but I recommend using SVG because it's
always for everything. You always recommend SVG like as the file format for every image type, even like with screenshots and all that.
So for screenshots, it doesn't really work because technically you can also embed the screenshot in SVG, but that doesn't make so much sense.
Yeah. Okay.
Whenever it makes sense, or whenever it is possible to use SVG, then I recommend to use that, because you can just zoom in and it doesn't get pixelated. But if I would zoom into this PNG file, if I would open it in a PNG viewer, then it would get pixelated once I zoom in. Also, the file size is much bigger and you can't really diff it. But SVG files, however, you can diff because SVG files are just text.
Yeah. Watermark was saying better. It's inherently better for diagrams. SVG is.
Yeah, but what I use the PNG feature, for example, is the logo of all my personal extensions. So I actually, the logo of a VS Code extension has to be in the PNG format.
Yeah.
And I designed the logo in Draw.io, and then I just named it Draw.io.png. And now all the logos of my extensions are editable Draw.io diagrams.
So how flexible is it as an image editing tool, right? Does it replace something like paint.net?
It depends. So I wouldn't use it as an alternative for like Adobe or something.
Because I use, I was using Figma. Everybody's using Figma now, right? Like that's the law, international law says if you're working with images, you have to use Figma, I believe. But yeah, paint.net. I used to use paint.net a lot. What is Figma? Figma is like a browser-based collaborative design tool. Would that be a good explanation?
Yeah. So it really depends on the use case, and you have to try Draw.io out to see for what it works. For small PNG files where it doesn't have to be like extremely professional, it's worth to start with Draw.io as a PNG file. You can also draw stuff. So there's a now I forgot where that button is. So there are different themes in Draw.io. You can actually change them here. And I usually use the I think Atlas one, and then it also has a different layout. And here's a freehand drawing where you can just draw stuff. But then
nice. Beautiful, yeah.
This is vectorized, so it's smooth, but it's not really suited if you want to be pixel perfect.
All right, so that's Draw.io, but we have a second extension that we're going to talk about, which is quite interesting. I've actually tried to use it before myself, and was very interested in whether or not it could help me actually solve some of these problems I was working through on LeetCode. So chat, I don't know about you, but when I try to solve these problems, I have like a for loop inside of recursion, and I can't keep track of in my head what exactly is going on, like what value is doing what. And so there you have another extension that can help with some of these things. Which one is that?
So the other extension that I did is the Debug Visualizer. Just search for Debug Visualizer, and then it's this one. And I can just install it.
Icon made with Draw.io.
icon made with Draw.io, of course.
There you go.
So I think this sunglass here is a SVG icon that I pasted into Draw.io, but then the background, the size of the picture, the color of the background that I all did in Draw.io. The same for the Draw.io. So the Draw.io extension itself is completely made in Draw.io, the icon of that. So these are just Draw.io nodes that I then exported as PNG.
Very nice. All right.
Yeah, the debug visualizer. So I just installed it. And so Draw.io is a tool that you can use to think about your problem before you even started coding. The debug visualizer is the other way around. So you already have some code and you either want to debug something, so something doesn't work and you want to understand why it doesn't work, or you want to understand how it works. And for that, you have the debug visualizer that can visualize stuff. And I can start with a quick demo here. So I have a super simple JavaScript here that I'm debug using VS Code. So I just pressed F5, and then that's the cool thing about VS Code. It's super easy to just debug JavaScript and then set up. So now I selected this term array, or R, and then I pressed Shift F1. Alternatively, I can also use debug visualizer new view. And then it opens this new window here, where it visualizes the value of the expression that I enter here. Then it can literally be any expression. So it can be some text, hello world. And this is not really impressive or surprising that for hello world, it just renders hello world, or for a number, it also just renders the number. But as soon as you give it some interesting objects, for example, an array, it renders them in various ways. So for example, this is a plot where it interprets these values as y coordinates on a graph.
Is there a way to visualize it as something else besides a graph?
So there are many visualizers. There is one for diffs actually. So if you have foo bar. Oh, sorry, this is a bug. Then it compares the difference between these things. So for example, here you can see that the 2 was added to the string. So this is a visualizer if you work with strings and change them a bit and then want to understand what changed in total, you can use this view to see the differences. Or if you make a check if this string equals this other string and it fails this check, and you want to understand why it fails, you can just compare these two string values here, and then it will show you the difference.
But for like the array of numbers, can you view that as like a set of blocks instead of the chart here?
Is a set of what?
Well, you know how like when I'm drawing an array, I usually draw it like
I see what you mean. Yeah. Yes. Yeah. So you can render it as I have to see. So there are various ways how this data is interpreted. This is specified by the extractor. So the extractor is basically what does this data mean, and the visualizer is basically render this data after applying this meaning here. And there is the extractor to interpret this as a grid, and then you get a grid.
There we go. Yeah, that's it. That's what I was looking for.
And this grid view has some nice extras. So of course, if you have an array that mixes numbers and text, it will just render the text in there. But often you have some pointers in this array or some index. And then you can just specify it, like this, I think. And then you have to select marked grid from array. So these extractors are suggested automatically.
So it adds the pointer to where you actually are in the array.
Yes. And now here, this is basically, this indicates the name of the pointer. And then I can say where it is, what's the value of this offset. And then this is the array. So now I can say 0, for example, then you can see the eye really moves there, so you can see what changes. And
Very
you
nice.
have a different value, for example. It supports to render multiple things here.
By the way, chat wants to know if you please go back to dark mode. I knew that was coming. You don't have to. Waterbank was asking, can you show it as a histogram?
I think Plotly supports. Oh no, Plotly not.
Okay. Let's see. Jose was saying, Debug Visualizer, like Python Tutor, could you create a dictionary or list? I mean, this is a list, right? In a sense, and visualize it.
I mean, this you can also. Okay, as a dictionary, this might not be suited that well, but as a list, certainly. Also, if you have, for example, an array of objects that have all the same shape, for example, first name, first name, Max, then you get this nice view. If you have other columns, for example, age, very realistic ages here. So then you have a view of a table. You can sort these columns individually, but here you can also visualize them in some other ways. For example, a chart. Or, So this component here is Perspective.js. It's an off-the-shelf component that I just integrated into the Debug Visualizer. Same as the plot of numerical values. This one. This is just Plotly, which is a library that you can use from JavaScript.
Now, you mentioned that we can use this against running code, right? To visualize the code as it changes?
Yes. So, for example, one great use case is when you do REST requests and want to inspect the data. So let's say you have this script where you go to some endpoint and request some data. Let me run it. So now we have this result here, but this is not extremely helpful. So it's extremely hard to make sense out of it and to ask questions like, how often is completed true? Or something like this. How many user IDs are there? And for that, you can just visualize this JSON value. And then the Plotly visualizer kicks in. And here you have your table where you can, for example, now sort by completed, or I can even group by completed here. And then I can say that for title, for the title column, I want the count. So I know that there are, for these to-do items, completed is false for 110 items and true for 90 items.
Man, that's super nice. What I usually do here instead is I get the JSON response and I like copy it and then paste it in another window so I can go like at least see it as JSON and go through it. But this is great. Yeah, I would use this for sure.
So you can see this is just running code. So I'm in the middle of debugging it, actually.
So, but the visualizer updates like as you change, as your code values change, yes?
Exactly. So I prepared another demo of debugging a linked list problem. If you like, we can go into that and I can demonstrate how to use the debug visualizer there.
Sure. Lucas is wanting to know if we can debug a binary tree.
For sure, but I don't have a binary tree example.
You can.
I mean, I could make it up, but I don't want to do
No, it's okay. We'll stick to the script, y'all.
So it's one thing to have the interview for an interview, but if many people are listening, then it doesn't.
Is it worse? Is it more nerve-wracking than an interview for the VS Code team?
Yeah, I think so.
Really? Oh,
because Henning. I know that there are so many people, and if I make a mistake, it's recorded.
It's online. Yeah, but it's a live stream. Making mistakes is like what we do. Plus, our chat's super nice. They're like the best people in the world. All right. What do we have here? So we do a linked list, y'all. It's kind of, I mean, it's not a binary tree, but it's a complex structure to keep in your head.
So this is a singly linked list, so the easy one. And here I have some code already. It's a bit of code. And let's say this code is from a colleague, and he says it doesn't, or she says it doesn't work. So I debug it. I set a breakpoint here. So what I heard is that the prepend function does its job, but the insert after function is a little bit weird. So this is why I placed this breakpoint in the insert after function. So now the general structure of this linked list is that the linked list has a head object, which is a node, and then a node has some data. So what I pass in here to the linked list, these values are the data 4, 3, 2, 1, and then 3.5. And next of the node is a pointer to the next node.
Yes, that's right.
So the linked list has a head and then points to a node, and each node can point to a next node, or it just points to null if it ends. So now here you can see it first points to 1, which is correct because we prepended 1 at the very last. So 1 should be the first item, and then 2, 3, 4, and then it should be 3.4 after index 2. So after 3, so it should be 1, 2, 3, and then 3.5, and then 4. Let's check with the elements that Visual Studio Code already gives us. So we see 1, 2, then 3, then 4. Okay, this is weird. Then 3.5. Okay, this is, I was expecting this to be before 4. And then 3. Okay, this is even weirder. And then it seems there is a infinite loop now. So something is really going wrong here. But I find it hard to see what exactly.
Yeah, this is where it's just your brain just starts to melt down because you're like, what is happening?
So with the debug visualizer, you just select this, press Shift F1, and this view opens, and let's see. So by default, it uses the toString extractor, which just calls toString on the object, so it's nothing useful here. But there's another option. There's the object graph. If we click on that, then we can nicely see that this is this linked list here, and then the head points to this node, and then the next pointer of that to this one, and the next pointer of this to the value 3, and then we have this weird cycle going on here.
Yes.
This is why from 3 we pointed to 4, and then was 3.5, and then 3.5.
Back to 3, then back to 4.
And this is just broken now. So this is not a proper linked list anymore. This is this is broken. So now we can understand what is going on. So maybe we can even debug a little bit. So if I press this here, restart, I just restart the program, and I will hopefully hit this breakpoint before it was broken. Maybe. Okay, I can see this looks much better now. We have the head that points to this node, and we have 1, 2, 3, 5. So this looks like a correct singly linked list.
Right. So far, so good. So this is the insert after.
So insert after, we have here the element before whatever this is and whatever get@add does. Probably it's the element before the node that we want to insert, and then we have element after, which is probably the element after the node, which is just the next element.
So at index 2 would be, so it's between 3 and 4.
Yes. So now we can actually use the debug visualizer to make sense of that. So there's one feature. If you pass in an object like this, then you can see there is now this object as the root object, which has the self property that points to linked list and so on. But now there is a different extractor. There's the object graph with pointers. And if I use that one, then I can see that this property here, self, actually now is this pointer. So I can use this to remember that linked list is stored in this variable self. I can actually use this here too. So this is basically what this points to.
Okay, so you don't keep track of what this is.
Yes, but now I can use, I can say element before. I want to point the value of element before, And we can actually abbreviate this in JavaScript. You can just remove this, and it means the same thing in JavaScript. So if we visualize this, then we can see, let's see what happens here. You can see that element before points to the node that has the value 3. So it's at offset 0, 1, 2, at offset 2, which makes sense because here we passed in the index 2, and then we called getAt, which probably gives us the node at offset here 2. The element before is now indeed the node at offset 0, 1, 2. So now let's check element after. So here we can see element after points to this, which is also correct. So now we want to insert our node between 3 and 4. So let's check what is going on with new node. So new node is still undefined because we didn't assign it yet. And let's step. So now we can see that this node here is floating around. It's not attached to our linked list yet. But now here we do some weird things. So let's just execute these steps and see what is happening. So this already looks very weird because
shouldn't it be pointing to 4?
Yes, and this one is also super weird. So actually, let's think about what we should. So I think these are the 2 lines that are wrong. And let's go back again. So I restart to see the fixed one. So now basically we want to have this node in between this. So there's one feature that I just recently added. You can copy this diagram and actually create a new draw.io diagram. Linked list.dio. And now, lots of windows going on here. Okay, this didn't work.
Kind of worked.
Let me think what the reason for this is. Is this the correct version? Okay, this is the current version. Okay, so I have no idea why it didn't work. But in theory, I would be able to paste this diagram as is into the draw.io diagram, and then I could move the nodes around and do some pointer arithmetic to really...
It's a new feature, folks. That's what happens.
Yeah. Live demos. So what do we want to do? So we want that the node element before the next pointer here points to this new node. So I think this new node dot next. So no, sorry. Element dot before. So let's add this here. Element before dot next should be my new node.
Yes.
Yeah. And the new node next should be element after, yes. So new node dot next equals element after. So let's delete these 2 lines that probably are bogus. And let's restart and let's watch what happens. So this looks good. Now we have the new node. This looks good. Now we basically cut off the linked list. Yep. So now it ends with 3.5. And now we have to continue. This looks really good. So I think
very nice.
That's the proper bug fix now.
That is crazy. I mean, I love that animation is great. So people are asking, will this work with Python or just JavaScript?
So in theory, it works with every programming language, but there are some complications. So it works the best with JavaScript. And I think just recently, someone from the community, from the open source community, added support for Ruby. So that might work as well. For Python, I think there's also support, but it might be a bit complicated to set it up.
Gotcha. So somebody was asking about C++, same answer.
So, same answer. C++ is a bit more complicated even, because in C++ you can't so easily evaluate arbitrary expressions. So mostly you can inspect variables, and then these variables have to store some some JSON in a very specific format for the debug visualizer to understand that. But for JavaScript, there's lots of magic going on that it's very easy to use.
Awesome. All right. Y'all, chat, I know we're running out of time, but we did say we were going to like solve a LeetCode question using these tools and like put this to some actual use. So we have one that we've picked out that requires a particular algorithm to solve. And so let's get into that. Before we do that, Henning, are you ready to do that before I?
Yes.
Absolutely. Okay. So just so we can see it here, I'm going to share my screen because I've got it pulled up. We're going to solve this problem right here. I think I've got it. Hold on. This one. Valid palindrome is the problem we're going to solve. This is this is marked as easy, although I take issue with the way LeetCode marks its questions. Some of the ones that they say are easy, I find impossible. And the ones that are medium, I find extremely easy. So it's up to you whether or not this is actually easy. Doesn't mean it's easy just because it's marked that way. But anyway, we're going to work together to solve this particular problem because this particular problem uses an algorithm called 2 pointers, or that's the way at least that they want you to solve it. So, all right, let's do that.
So for time reasons, I suggest to ignore white space and don't use 2 pointers but a single for loop. But we can see how.
Okay, yeah. Show us how we would solve it here.
So palindrome.js. So the goal is to implement a function is palindrome of a string, and let's tell the system that string is actually a string, and we want to return a Boolean. Palindrome. So as a test case, I think there was the race car word that is a palindrome indeed. And so a very easy way would be, I think there is no reverse function. But in this case, let's say the definition of a palindrome is if the reversal of a string is the same as the string.
Yeah.
But we don't actually want to compute the reverse string because that might be a bit expensive. So let's check. So my idea would be, now maybe draw.io might be handy. I want to compare the first character with the last character, and if they are not equal, then it's surely not palindrome, because when you reverse it, the last character becomes the first, and if the reversal is equals to the non-reverse string, then that's a requirement. So I compare the first character with the last character, and then the second first with the second last, and so on. And if they all agree, then it's a palindrome.
And this is more efficient than just reversing the string and comparing them, because you could figure out that it's not a palindrome much easier because you're coming in from the edges. So the second that you determine that it's not, you're just out.
Yeah. So from a complexity theory point of perspective, it has the same worst time complexity, because reversing a string is linear time. And for palindrome, you also have to have a look
at also linear time.
It's also linear time. But in practice, if you don't have to allocate new memory, that's just significantly faster.
So if it was a huge palindrome, this would be significantly faster.
Yeah,
so
I would expect it to be 10 times, if not 100 times faster.
Okay, so it's not a time complexity, it's a space complexity saving.
It's space complexity saving, yes.
Okay.
Yeah. So, so we have a simple for loop where we iterate over all the characters in the string. And then we have the I at the end, so at the reverse one. And this is string.length minus I. So now we compare string at length I with string at length I reversed. And if they don't agree, we return false. Otherwise, if they all agree, then we return true here. So I think this maybe does it. So let's see. So I put a breakpoint here and I run code. let's visualize the string. So this is the input race car. And now let's use the view where we can render pointers in a grid. So that would be, we want to render I and I ref.
All right, so just to clarify what you just did there, you just destructured the string into an array. So it just makes it into an array of RACECAR in individual spots in the array. And then the second object there defines the pointers that you're using. Is that correct? What I points to and what I rev points to.
Exactly. Currently they don't show up because they are undefined, but as soon as I step
there's I, under R.
But now I can already see.
And I rev is actually.
Sorry.
Yeah, so I rev is actually outside the bounds.
Yes. So this might point to a problem here because now we compare string at position I is R, and string at position I ref is
nothing.
Undefined.
It's going to always be false.
So this is going to return false, exactly. So now we immediately spotted the problem we didn't even have to execute it, just the visualization was enough for us to see what the problem is. And actually the problem is that we have to subtract 1 here. And this is because the offset of the last element is not the length of the array, but length minus 1. So if you have an array of length 1, then the offset of the last element is 0, which is this confusing problem off by 1. It always happens to me.
They should have just had arrays start at 1, and literally 90% of the problems in programming would go away.
Actually, it's good that an array starts at offset 0, I think, for other reasons, because 0 plus 0 is 0. So you can use your offsets as they form a group. So you have a neutral element, and this is very useful for some.
Aren't there some languages where they arrays do start at 1? I know there are.
There are. I think I forgot which language there are. But there are also languages where you can specify it, which offset.
Nice. Okay. This is more things for programmers to argue about.
So okay, let's restart this problem here and now see what happens.
Yeah, Lua starts at 1.
So now this looks much better. So iref is now R, and we compare them, and they're equal, so we don't return false here. Now we just incremented I by 1. Iref is now it's also decremented by 1, and A equals. So this looks good. This looks good. Okay, this looks weird a bit.
We went too far.
We went a bit too far. So in theory, it's the same, because now this C equals this C, and we do the same checks, but now we basically swap these operators, these arguments here. So one optimization we can do is it's sufficient to just go to the middle of the array. And then let's check this. So here, go here. And here we compare E with E, which technically is not necessary, but this is the last case, and then we skip, so this looks good.
Oh, you know what? I would not have done that. I would have compared I and iRev. But I guess inside a for loop, you can yield from a for loop, can't you?
Yes, you can just
return. That's actually a more elegant solution than what I would have done, which is why I'm not on the engineering team, isn't it, Henning?
Well, I think exiting the loop when I is bigger than or equals to iref would be even. I think it would be cleaner, because then you don't have the issue what if length is odd, and then weird things happen. So actually, suggestion is a bit cleaner. So, but then I would do a while true loop, maybe even. So it's weird then that this condition basically is never false. Then if you always do the early exit, then this condition is never false, and then you don't. Then it's weird. Then you could write anything here. and false, and it would have the same effect. So that's also weird code.
Very nice. Well, folks, that's that. So we did Draw.io for diagramming and for visualizing data structures, and then Debug Visualizer for actually using it as you move through your code. You can use this when you solve your LeetCode problems. Does the visualizer support like linked list, binary trees, queues, hashes, the whole nine?
So there's a playground of all these visualizations online. So everything is open source here. The entire Debug Visualizer and all libraries I use there are all open source. And in this playground, you can see which visualizations are all supported.
Perfect.
So there's this graph visualization, and there's a visualization for abstract syntax trees, which is very useful when you try to implement refactorings, and then you can actually see the syntax node and what section of the code this syntax node refers to. That was very helpful.
I'm just looking through here because somebody asked a very interesting question. Like,
you can add your visualizations now. So there are two things that you can do. You can implement your own extractors, and these are configurable. So in your settings, you can point to JavaScript files that provide some extractors, and they get this object that you enter here, and they can basically return a different representation. And then they can make use of all the existing visualizations. And for example, if you have a rich class where you just want to enter this here, then you can implement an extractor that converts this to a graph data thing that then the graph visualizer understands and can visualize. But you can also contribute custom visualizers, which then extend basically this view. But implementing a visualizer is a bit more complex because you have to use React, and coming up with implementing visualizations is always a bit tricky. But extractors are super easy.
But you're accepting contributions right now.
And that too. Open source and
always accepting contributions. So yeah, go try it out. Bogdan's going to try it with C#, see how it handles, and make a PR to the Debug Visualizer. Will help more people get through their LeetCode questions. All right, chat. That's about it. Unless you have any other questions, now's the time to get those in. But other than that, we're going to wrap it up and get to our lightning round with Henning. Let's do the lightning round.
I have no idea what the lightning round is, but
great. It's where you get to answer a bunch of questions that are controversial that you don't want to have to answer. You're going to love it. Let's see here. All right, you ready?
Yes.
Lightning round. Light theme or dark theme?
Light theme. Sorry, folks. I can't think. If I see a dark theme, I feel very closed. But if I see a light theme, it's all open-minded, and I can be much more creative.
You sound like Headspace. More space in your mind. Yes. More space to think. That's interesting. I've never heard people explain it that way before. Okay. That was the wrong answer, but thank you for your answer, Henning. TypeScript or JavaScript?
TypeScript, definitely. Or what is JavaScript?
Types or no types?
Types.
Really?
Types are the way.
Why do you need a computer to tell you that something is a number? You know it's a number. The computer should know it's a number.
I don't know that's a number. Especially if I have to deal with code that I didn't write, then I don't know that's a number. Also, it's not just the computer telling me stuff, but it offers so many tools that are only available if you have types. So for me, I wouldn't even touch projects that don't have types.
Wow. All right. Wow. Wrong answer again, but thank you for your input there. Okay. Coding. Is it coding or is it programming?
Coding or programming. It's both for me.
There's a huge debate out there about whether or not chat, is it coding or is it programming? What do you call it?
Coding. It's easier to speak to just say coding.
I feel like coding is the modern take on it, right? Like if you're programming, programming development.
So actually, I prefer engineering.
Engineering? The only difference is like for engineers, you have to be like licensed. I feel like if we're going to be engineers, maybe we should have to get licensed.
No, I think for me, engineering is that you think first, or that you don't just code and type. So coding
Yeah.
is for me, but engineering is about first think about the problem, explore ideas, maybe even in Draw.io and diagrams, think about it visually. And only then, when I have the feeling I understood the problem very well, I start coding.
Very, very good point. I agree with that. Last question. Best language if you want to learn programming. What's the best language for learning?
That's a good question. I could say the lambda calculus, but there might be people who disagree there.
The what?
The lambda calculus.
Lambda calculus?
It's one of the first programming languages, and it's extremely simple. It only has 3 concepts. So minimal syntax, and it's Turing complete. So you can compute everything that you like with that.
It only has 3 concepts?
Yes, it only has, you can call a function, you can define a function, and there are variables. That's it.
Wow. Okay. Lambda calculus. That's it, folks. You heard it here. If you want to learn how to program, check out lambda calculus. I've never heard of that in my life.
JavaScript, I think, is a good start, and then TypeScript is even better.
All right. Well, thank you so much for being with us, Henning. These are great. Producer, can we throw up the, do we have links for Henning's extensions? Did we send in links? There we go. There's the Debug Visualizer. Does it go, and do we have one for Draw.io? There we go. So aka.ms/Draw.io/Debug Visualizer. That's all you have left to do is go grab those extensions today. Why haven't you done it already? I don't know. All right. Chat, thank you for being with us. Henning, thank you so much. I know you're busy. I'm not sure what VS Code feature we're not going to ship because you had to take the time out to do the stream, but we won't keep you any longer than we have. Thank you so much for your time. Thank you, chat. We will see you back here next week for the release party coming at you. Bye, y'all.
Bye.